Hello, everybody. It's Mr. Joseph again. I'm back, and we're going to do some more factoring today. So, if you watch the first video, you see that we did two factoring problems where a is greater than 1. And on the third one, we are also going to do one where a is greater than 1, but there's a little twist to this. I hope that you can see. I'm going to write this in big words, GCF. Greatest common factor is a great friend. It always helps you make your bigger problems into smaller ones. So when I look at this, I notice that there's a 16, a 60, and a 100, and I see that these are all even numbers, so I know that they're all divisible by 2. So in my head, I should think, oh, okay, I can take a 2 out. But before I take a 2 out, I might ask myself, is there a bigger number I can take out? And in this case, yes, there is. It is 4. Remember, you'll have a calculator. You can also use that to assist you, but also just getting familiar with numbers, you'll start seeing patterns of, oh, this is all divisible by 4 or by 8 or by 10. But in this case, all of these numbers are divisible by 4. So I take a 4 out and I ask myself, 4 times what gives me 16b squared? That would be 4b squared. 4 times what gives me 60? That's going to be 15b. And 4 times what gives me 100? That would be 25. So the good thing about this is I can technically distribute it and check if it gives me back my original statement, which I hope that you see it does. So that is the first step in this process. The good thing now is instead of having to deal with 16b squared and a 60 and a 100, I'm now just dealing with a 4, a 15, and a 25, which I hope you'll see makes the problem a lot more approachable. So I'm going to keep this 4 on the outside, and I'm going to factor this part right here. So I know that looks like a trinomial, so I can go ahead and put the 2 parentheses. And I know here I have 2 options. I can write 2b and 2b, or I can write 4b and b. You have to kind of figure out which one you think is going to work, and it's kind of trial and error. So let me just go ahead and write both of them so you can look at it and maybe determine for yourself which one works better. And of course, I write the same thing, which is not helpful. So 2 and 2. All right, so we want two numbers that multiply to a negative 25. So when I write 25, I know it's 1 times 25 and 5 times 5. And I know I want to add to a positive 15. So let's think here. If I do 4 times a number, I probably would do 4 times 5, because 5 times 5 I think is going to be a better option because 25 seems too big. So if I do 4 times 5, I see that that gives me 20. And I'm not hating on 20 because I know if I put a 5 there, then I'm going to have to put a 5 here. And I know the two numbers need to multiply to a negative 25 and add to 15. So I know one of them has to be positive and the other one has to be negative. And I hope that you see here that 4b times 5 is 20b, and negative 5 times b is negative 5b. And you see how 20b minus 5b gives us 15b. So that actually works out, and I get my answer. Once again, I just wrote both options. I can look at 2. If I put a 5 and a 5 there, that's going to give me 10b. That's going to give me 10b. But that's not going to give me 20, no matter what I do with the signs. I can make this positive and make this negative, and I actually get a 0. 10b minus 10b is 0, so that doesn't work. So I'm just going to go ahead and erase this. And as you can see, we have our answer, which is this right here. So I know I said last video I wasn't going to find zeros, but I'm going to go ahead and find my zeros for this one. When you're finding zeros, you never worry about the coefficient. Let me not use that color. The coefficient, you don't have to worry about that. You just take your parentheses and you set them equal to 0. And you solve them. Most people feel comfortable with this one. They don't even write -5 because they know it's just going to be the opposite sign. But I want to make sure on this left side that you actually do go through the process of solving an equation, which is going to give you 5/4. So your two answers are b equals 5/4 and b equals 5. These would be your zeros, and what I boxed would be your factored form of the problem. So don't forget the greatest common factor is your friend, and this is a little twist to our regular a is greater than 1. So I'm going to erase this. Every video, I'm going to see if I get better at erasing, which I feel like I was really good before, but maybe the pen is not big enough. That's fine. All right, now I'm going to scroll up, and we have made it to question 4, which is 2x squared minus 2. I'm going to do this real quick just to show you how smooth this process is. I see here a 2 and a 2, so I'm going to factor out a 2. And 2 times what gives me 2x squared, x squared, and 2 times what gives me -2, -1. Remember, whatever you factor has to take you back to where you started. And if I distribute it, it will take me back to my original. Based on my few observations, a lot of us are missing the fact that this can be factored. This is called a difference of squares. So the way that you do this is you ask yourself, what two numbers multiply to -1, which is our products, and adds to 0? Do you see how there's not a 0 there's nothing in the middle, so that means it's actually 0x. So what two numbers add to -1 and add to 0x? If it helps you, you can write it like this. You can think about it like that. But I hope that you see that it's -1 and +1. And it'll always be the opposite signs and the same number. And that's how you factor number 4. And just like that, you're done with that. And then our last example is number 5. Okay, and this is another one that looks different, but there's so many suspicious things here. So for instance, you should be suspicious that 16 is a perfect square and 121 is a perfect square. So that kind of just gives me a hint, maybe I might be able to do difference of squares here. I know my signs have to be the opposite, and I ask myself, what two terms that are the same give me 16x to the 4th? I hope that you see that is 4x squared. What two terms that are the same multiply to 121, y to the 4th? I hope that you see that's 11y squared. And if you don't believe me, that's okay, because we can actually distribute here and we can check if we get our same answer. But first thing I want to do is I just want to box this Christmas looking problem. So that is your answer, but if you wanted to check it, you would just have to distribute and see if it's going to give you the original. So 4x times 4x is 16x to the 4th. 4x squared times minus 11y squared is 44x squared y squared. 11y squared times 4x squared is 44x squared y squared. And the last one is 11y squared times -y squared, which is 121y to the 4th. I hope you pay attention to this middle parts right here and you see that these should subtract to 0 because they're the same thing and they're opposite signs, so that goes away. And you are left with 16x to the fourth minus 121y to the fourth, which is the original problem that we had. So we have successfully checked it, and this right here is the factor form. Thank you.